A graphite cylinder holding 3 kilograms of plutonium rests in the silt 10,000 meters below the surface. Why did the planet's fastest tectonic collision zone become the tomb of a space mission? We will observe how the Tonga Trench swallows the Pacific crust and safeguards artifacts fallen from outer space. In April of 1970, the world watched as the Apollo 13 module re-entered Earth's atmosphere. The mission had failed, and the makeshift lifeboat craft needed to be discarded before the main capsule's landing. Most of the aluminum and titanium structure disintegrated in flames above the South Pacific Ocean skies. But one specific component was designed by engineers to survive any impact scenario or extreme temperature. The radioisotope thermoelectric generator, loaded with nuclear material, did not burn up. It struck the sea surface and sank like a heavy anchor through the blue waters of Polynesia. It descended beyond the sunlit zone, passing through the abyssal plains and entering the darkness of a vertical canyon. This colossal geological scar, reaching a maximum depth of 10,823 meters. It is the Tonga Trench. If Mount Everest were placed at the bottom of this trench, its snow-capped peak would still be submerged by 2 kilometers of water. The radioactive generator hit the bottom and remained there, enveloped in darkness, where pressure exceeds 1,000 atmospheres. Under 1,000 atmospheres of pressure, the radioactive generator rests at a location known as the Horizon Deep. This is the deepest point of the Tonga Trench and the second deepest place in all of Earth's oceans. The trench stretches for over 2,500 kilometers, tearing the ocean floor from north to south. It forms an invisible and violent boundary where the gigantic Pacific Plate meets the Tonga Plate. The dynamics here are of pure geological destruction. The heavy Pacific Plate is diving beneath its neighbor in a continuous, inexorable process of subduction. The speed of this dive is the fastest ever measured at any tectonic boundary, reaching 24 centimeters annually. It may seem a small measure on the human scale, but in the vastness of geological time, it is a high-speed collision. This constant friction over thousands of kilometers generates an environment of extreme seismic volatility. The oceanic crust scrapes against the lower layers. This melts massive rocks and feeds underwater volcanoes along the trench margin. The trench acts as a gigantic funnel. It pulls sediments, icy water, and any debris that falls from the surface. To understand the true scale of this tectonic funnel, science needed to send instruments down the same vertical path taken by the Apollo 13 wreckage. And the data collected by these expeditions revealed an abyss far more unstable than surface sonars could detect. The unstable abyss mapped by modern sonars reveals a topography that challenges contemporary naval engineering. In June of 2019, the limiting factor submersible began its descent into the waters of the Tonga Trench. Pilot Victor Vescovo watched the LED depth gauge. Sunlight completely vanished within the first 1,000 meters. The vertical descent through the canyon took over 4 uninterrupted hours. The water temperature dropped to about 1 degree Celsius, and the pressure outside the titanium protective sphere increased relentlessly. The submersible's acoustic beams mapped sheer basalt rock walls, steep and severely fractured by continuous seismic activity. Unlike calmer areas of the ocean floor, The Tonga Trench features slopes that appear to have collapsed just hours ago. Landslides frequently sweep the canyon floor. They create dense clouds of sediment that take weeks to settle. When the submersible finally touched the soft bottom of the horizon deep, the instruments on board recorded the exact mark of the descent: 10,823 meters deep in the horizon deep. It's a marginal difference compared to the Mariana Trench's depth, but the physical dynamics of the seabed are fundamentally distinct. The robotic vehicle switched on its main spotlights. It illuminated the light sediment, searching for geological anomalies at the bottom of the world. The expectation was to find a desolate landscape, sterilized by colossal pressure and the absolute absence of sunlight. But what the cameras revealed on the plains of fine mud forced the mission's biologists to revise their theoretical models. But the plains of fine mud were not the sterile deserts that extreme pressure suggested, where only crushed rock and the silence of a geological tomb were expected. The sapphire lenses of the cameras captured constant movement. Small amphipods, translucent shrimp-like crustaceans, swam frantically around the submersible's headlights. They scoured the bottom in search of any particle of organic matter that completed the long journey from the surface waters. The real question shifted. How does biology thrive in the Pacific's fastest collision zone, sharing the chasm with radioactive debris? The answer lies in the very violence of subduction. The Tonga Trench is so seismically active that its frequent tremors cause massive collapses on the canyon's sidewalls. These underwater avalanches carry tons of nutrients from shallower zones to the bottom, feeding the Hadal zone creatures. It's a conveyor belt of organic matter driven by the energy of earthquakes. As the Pacific Plate is pushed into the Earth's mantle, it sustains a specialized ecosystem on its surface. Researchers observed pale snailfish swimming slowly, with gelatinous bodies hovering over newly exposed volcanic rocks. They withstand forces that would crush the steel hull of conventional military submarines in fractions of seconds. Local biology has adapted its cellular structures and essential proteins not to collapse under the weight of almost 11 kilometers of water. An organic resilience that continues to be tested by the rigorous readings of radiation and temperature sensors in the region. The radiation sensor readings point to a delicate, silent balance between Hadal biology and extreme geology. The Apollo 13 plutonium generator fell exactly in the center of this natural tectonic plate grinding machine. The graphite casing was built with rigorous tolerances. It was meant to withstand atmospheric re-entry without leaking its radioactive core. Deep water samples taken in the Tonga region over the past 50 decades confirm a crucial scientific fact. There are no traces of abnormal artificial radiation escaping into the Pacific Ocean currents. The cylinder remains sealed and intact, surrounded by amphipods and snailfish, resting more than 10,000 meters deep. But the Tonga Trench is not a static museum where objects remain untouched forever. Due to the record subduction speed of 24 centimeters per year, the entire ocean floor is in constant motion. Slowly, the immense Pacific Plate is pushing everything resting upon it towards the Earth's incandescent mantle. This includes the basaltic rocks, the accumulated sediments, and the heavy space-age thermoelectric generator. In a few million years, the plutonium intended for the moon's surface will be swallowed by our planet's molten interior. The trench acts as Earth's ultimate geological dumpster. What began as a triumph of engineering in the human space race will end up melted and assimilated in the deep tectonic furnaces. Until then, the dark graphite casing is just another anomalous stone on the vast, silent plain of the horizon deep. A silent anomaly that forces us to recalibrate our understanding of the ultimate fate of things. The understanding of the horizon deep reveals something greater. It is not just an isolated hole on the Pacific Ocean map. The planet's fastest collision zone became the tomb of Apollo 13 purely by gravity and abyssal geography. Its depth of over 10,000 meters captured the falling generator. It was permanently isolated from the surface biosphere. The pressure of 1,000 atmospheres holds the cylinder in place while the side trenches continue to collapse around it. Relentless geological activity ensures the next step. On the scale of deep time, this human artifact will be recycled by the Earth's bowels. The Tonga Trench documents something greater. The ocean possesses mechanisms of destruction and renewal that surpass any engineering we can conceive. In our next episode, we will investigate the Dumbo octopus, the strangest creature in the scariest place on the planet. Its translucent fins pulse slowly in the icy darkness of the abyssal zone, hovering over the black basalt without haste, without making a sound.